So today we're going to learn this method called substitution method. This is for solving systems of linear equations. Okay. Do you remember last time one of the way of solving systems of linear equation was using the graphing method? We graphed two lines. We looked at where the intersection was, and we figured out that that was the solution for both of these lines, right? This method does not require you to graph, so this is kind of nice. And also, another nice thing about this is, let me ask you this. When you're graphing these intersections, do you think there will be time where the graphing does not give you the accurate intersection?
Yeah.
When would that happen? When would you not get the really accurate intersection? Yeah. Kevin? Right, if the intersection happens to be not like on the grid, right? If it's not some integer, if it's like 2.4, you can't really tell exactly what that is. So using substitution method, you could actually get exact intersection, okay? Even if it's fraction or things like that. Does that make sense? So yeah, the graphing method is kind of nice because you see the actual intersection, graphically it's nice. Here, with the substitution method, without graphing, you could actually figure out a precise intersection. Okay, does that make sense? So that's kind of an advantage of this. So let me show you how to do this. So write this down. In the substitution method, we use either equation to solve for one of the variable in terms of the other. Okay. Okay. And we'll do an example. But this is not all. After you do this, and if you're not quite sure what this means, when we do an example, it'll make more sense. So you solve for one of the variable in terms of the other from one equation. Then you obtain a third equation. So you're going to obtain a third equation involving only one variable by substituting. Okay, so write this down. And if you're not quite sure what it means, don't worry about it. We'll do an example. It'll make sense. Okay, so I'll give you some time for you to write. So what do I mean by this? Well, does anybody know already? Do you have an idea? What do you think? Yeah, that's basically exactly. So here, if we do an example, it'll make sense. So here's an example one. I have two equations. That's why we have a system. So it says solve by substitution method, and Maddie is correct. So we got 2x plus y equals to 9. X plus 4y equals to 1. What we're going to try to do is, first it says we use either equations to solve for one variable. So it doesn't matter which equation you use. Which equation would you like to use? First one or the second one? First, let's use the first one. It doesn't really matter. And which variable would you like to solve for? It says solve for one of the variable. Would you like to solve for x or y? Yeah, y. Aaron, why do you say y? Yeah, it's alone already. It's easier, right? If I were to solve for x with the first equation, you would have to divide by 2 and you get fraction. It's not as easy. So that's what you would do. So you will solve for x. So that's what this first sentence is saying. In the substitution method, we use either equation, first one or the second one, to solve for one of the variables. So I chose the first one and I chose to solve for y. It's easier. And then, what does the second sentence mean? Then, obtain a third equation by involving only one variable by substituting. What do you think that means? I think Maddie's got that one. Colby, you have an idea?
Oh, like you substitute what y is from the second equation to negative 2x plus 9.
Exactly right. In place of y, since we have solved for y, guess what we're going to do? In place of y, we're going to substitute what? Negative 2x plus 9. That's why it's called substitution method. And do you think it's a good idea to substitute back to the first equation? No. Then you get this. It will be always true. Okay, that doesn't do any good. So you need to use the second equation that you haven't used. Plug that into the second equation where the y is. Now, when you plug in, you should always use parentheses. If you don't, it's easy to make mistakes, right? So please do that. So can somebody tell me what to write? When you see I drew the arrow there. Let's see. Yeah, Chansu, what should I write?
X plus 4 times negative 2x plus 9.
You got it. Okay. Does that make sense, guys? The third equation, you plug it in using parentheses. I substitute whatever that y was in place of y on the second equation. That's why it's called substitution method. then of course, look at what we have. It says then obtain a third equation involving only one variable. Do we have only one variable? The third equation? Yeah, we only have x. That's nice, because what can we do with this equation when you just have x? Yeah, Maddie? We could solve for x. Everybody go ahead and do that. Okay, see what you get. Give it time. So when you do, so what should I do here? Savannah, how should I find x? Exactly, I distribute 4 to find, so solve for x. Then did you all get x plus negative 8x plus 36 equals to 1? And when you solve, how many people got 5 as the x? Good, good. We're done, right?
No.
Oh, we're not? Why not? You're right. We're not done. Okay, Derek, we have to find y. Why? Why does the solution of this system has to have y also? Yes? It has to be an ordered pair. We only have one. See on the left, I have the drawing. When the two lines intersect, right, the solution is an ordered pair, not just one, right, x coordinate. So this is the only x coordinate of the intersection of two lines. So how do I find y then? That's great. Okay, so we know that we need one more coordinate. How do I find y coordinate? Owen?
Like you plug in the 5 with x and plus 4y equals 1.
Exactly. So you plug in x into which equation? First one or the second one? How many people say first one? Raise your hand. So how many people say second one? How many people say something else? Yeah.
Just plug it into what you put into the value of y. Like you put y equals 2x.
Oh, is that what you mean? Okay, sure. So it turns out, but is it okay if I plug into the second equation?
Yeah.
How many people say no, you cannot plug into the second one? The answer is, it does not matter. So how do I find the y coordinate? The answer is, plug in x into the x we just found, into any one of the equation we had, the first one or the second one. It does not matter. Why does it not matter, you think? Yes, Kobe?
Oh, because like that point is in both of the lines.
Exactly. That point belongs to both of the lines. That's why they intersect, right? That's where they intersect. Does that make sense? So, okay, so to make a point, why don't you guys on the left, all you group on the left, plug into the first equation. See if you get the answer. So you guys plug on the right side. Why don't you plug into the second equation? Let's see if we get the same y coordinate. Go ahead, everybody do that. Because yes, that's where they intersect. It doesn't matter which one you plug in. It's a solution for both. Okay. Go ahead. Okay, so you guys on the left, all you groups on the left side, what did you guys get when you plug in? -1. So 2x plus y equals 9. You plug in 5 there. You get -1. That's good. Okay, on all you guys on the right side, when you plug this into your second equation, what did you guys come up with? -1 also, isn't it? So it doesn't matter which one you plug in, you get -1. So second equation here's the work. You get x plus 4y equals to 1. You could plug in 5, and then you get y equals -1. Right? Does that matter? Okay, so it doesn't really matter which one you plug in. By the way, which one was easier to plug in? The first one, kind of, because didn't we already solve for what? Y. So that's what Cameron was trying to say. The first equation, didn't we solve for y already? So what was y? Y was equal to -2x plus 9. You plug in, you get the answer right away, but it doesn't really matter. Okay. Do you guys get the idea? Okay, why don't you try then second equation, second system. Go ahead and solve this system using substitution method. X minus 2y equals to y, and then 2x minus 5y equals to 4. Okay, go ahead, try this. Okay, so let's think about this one now. Which one should we solve for? On example 2, should we solve for x or y from the first one to the second equation? How about one person thinks they know? Shrug, what would you do?
We solve from the first equation.
Which variable would you solve for?
X.
X. You wouldn't solve for y from the first equation because you get fraction. Would you solve for x or y from the second equation at all? No. I wouldn't, because you can. It's just you get a bunch of fractions and you don't want to make it harder than it is. So okay, so we will solve for x. It's easier. You add 2y to both sides. Did you all get x equals to 3y? Okay, when you plug this in, Sarah, tell me what do I get here? Yeah.
You get y equals 4.
Oh, okay. So what's the third equation you get?
You plug it in, so you get 6y minus 5y equals 4.
Good. So yeah, when you plug it in, did you all use parentheses?
Yes.
2 times 3y. Now imagine if you didn't put parentheses. What could you think this might be? Yeah, it might look like 23y. You may have little dot, but still. So please use parentheses. So you get 6y, and then you get, did you all get y equals to 4? Okay, and which one would you like to plug in? First one or the second one? Yeah, you could just plug into the first one. You already solved for x, right? So what does x equals to 3y, correct? So I think I plug in there. What did you get? 12. Okay, so how many people got 4 comma 12? Raise your hand. That's how you get it wrong at the end, guys. Please do not write 4 comma 12. Okay? Why not? That's what we got, 4 and 12. Anais, why not? Thank you. It's x comma y, not y comma x. Please don't make that silly mistakes at the end. Sometimes people do that because they're in a hurry, you know, when they're taking the tests and quizzes. Make sure you put them in that correct order. Sometimes when you solve for y first, people have tendency to put that one first. Okay, please don't do that. Okay, that will be a very different solution, right? Anyway, any question? You get this? Can you try? Do you think you could do one more? Pretty straightforward. Okay, try this one now. Oh, before I get to, I'm sorry. So write this down. If you have time during tests, or okay, of course you have time during homework. If you want to make sure you have the right answer, right? How do you check? How can you check? You can check by, yes?
Plugging into the other equation.
Plugging into the other equation, not correct. Yes?
Just plug it back into the original equation and get.
Plug into the original is correct, but which original one?
E1.
We have 2 equations, right? We have 2 original equations, right? Which one do we plug into? This is important. Second one? The answer is, and you, Kyle, what do you think? What do you think? When we're checking this, right? There's a way to check. Which one? So we said we're going to plug into the original one. Which one? Which original one? First one or the second one? Both is correct. Derek, why do we have to check into both?
Because since that's where they intersect, it has to be a function.
Exactly. You have to check, you have to plug into the both original one, because it may work for one. Does that necessarily mean it's the solution for the other one also? No. How many solutions are there for one line? How many solutions does one line have? Infinitely many. These are order pairs, right? That makes up the whole line. It could be true for that one line, but it may not be true for the other. We're looking for the solution of the system. So therefore, you need to check, to plug into both of these original equations. Why do you think I highlighted original? Why can't I plug into, I don't know, like x equals to 3y? Why do you think it's best to plug into x minus 2y equals to y? Something like that. Anybody? Yes? Yeah, you could have made a mistake while, you know, solving for one of the variable. I mean, this one is simple enough, but, right? Some of the other ones, they may not be so simple, right? So just, right, just to check and see if you actually solve for one of the variable correctly, you should always plug into your original equation. Does that make sense? And you gotta check you gotta check both of the original. Otherwise, right, it may not be your solution. Okay, now you're ready for this one. Go ahead. Example 3, y equals to 4x minus 5. 8x minus 2y equals to 20. See if you can solve the system using substitution method. Okay, go ahead. So, some of you are mentioning this. It's kind of different than the other one. By the way, which variable would you like to solve for? Y. That's kind of obvious. Look at the first equation. It's already solved for y. You don't have to do much work. You probably don't want to solve for anything else from the other one. So you get, yes, let's plug it in. When I plug in place of y on the second equation, so did you all write down 8x minus with minus 2 parentheses 4x minus 5?
Yeah.
And you say, well, this becomes a little bit interesting. So you get 10 equals to 20. What does 10 equal to, guys? 10 equals to 10. 10 doesn't equal to 20, does it? So, what do you think this means? This is a false statement, right? 10 doesn't equal to 20. So raise your hand. What do you think it means? Derek? That means the lines are parallel. In other words, so if the lines are parallel, what do you think your solution is then, Cameron? No solution is correct. So this one, what does it mean? It means lines are parallel. So you have no solution. Remember we did this last time when we were doing graphing method, right? When the two lines are parallel, when they have the same slope, different y-intercept, do they ever intersect? No, that's why you get this sort of, right, equation here. You get a false statement. Do you guys get that? Okay, why don't you then try this one right here. Example 4. 2x minus y equals to 1. And 3y plus 3 equals to 6x. Go ahead, everybody try. the other one too. So let's, first of all, which variable would you like to solve for? How about Harrison? Which one would you like to solve for?
Solve the
First one, and which variable?
X.
X?
No, Y.
Oh, y. Because if you solve for x, you gotta divide by 2. So let's solve for y. You add y to both sides and then subtract 1. What do you get? Y equals to 2x. 2x what? Minus
Minus 1.
1. Yeah. And let's plug it in here. You get, in place of y, who could tell me? Christine, tell me what to write here. Yes. And you distribute this. Did you all get 6x equals 6x?
Yeah.
Or if you want, you could divide both sides by 6. Either case, the left side would always be equal to the right side. What does this mean? This is always true. You get what? These are same line, right? Remember? So guess what? Infinitely many solutions, right? Remember we did this with graphing method? You get same line. This if you wanted to, you could verify. The second equation you could solve for y, it'll come out to be y equals 2x minus 1, just like the other one. So yes, when you get a true statement, this is always true, isn't that right? So therefore, you know that any order pair you plug in. Well, not any order pair. Does this mean you can plug in any order pairs on an x and y axis? Which order pairs would it work?
On the line.
Yeah, any order pairs on that line will work. Very good. Any question? Do you guys understand? Natalie, does this make sense? Yeah. Very good.